Welcome to Easy BTech, your guide for BTech and beyond. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss Cmos inverter stick diagrams. Cmos inverter stick diagrams. Stick diagrams. Last class we discussed about NMOS inverter stick diagrams. NMOS inverter stick diagrams. So the stick diagrams for different logics of NMOS, how it will be designed. Now what is CMOS inverter? You can draw the circuit diagram, then we'll see the stick diagram. CMOS inverter, it is a complementary metal oxide semiconductor. So first above is a complementary transistor, that is a Pmos transistor. You see this one. This is a Pmos transistor, complementary transistor, pull up transistor, and pull down is an enhancement mode transistor. You can see this one. And a common input is applied to the two terminals. It is a common input is applied to the two terminals. Okay. It is a VDD and VSS, Vout, and input is a common input to this one and bubble across the gate terminal. So it is a complementary MOS transistor act as a inverter. So this is Pmos transistor, bubble across the gate terminal, Pmos transistor, and this one is NMOS transistor. NMOS transistor. You know the stick diagram for Pmos, stick diagram for NMOS we discussed in previous class. So what is NMOS? NMOS stick diagram. NMOS stick diagram. So this is NMOS stick diagram, red over green. You can take this red over green. Polysilicon is a gate and green is a diffusion, N plus diffusion. The basic layers are N plus diffusion for NMOS, P plus diffusion for PMOS. Now it is a gate, drain and source. It is NMOS transistor. This is NMOS enhancement. NMOS enhancement transistor symbol. Enhancement. NMOS enhancement transistor symbol. Now this one is a gate terminal. Now drain and source terminals. Drain and source terminal. So it is a stick diagram. This one is a stick diagram. Stick diagram of NMOS. Stick diagram. Stick diagram. Pmos transistor. Let us take the Pmos transistor. Pmos transistor is a symbol, Pmos symbol. This is a Pmos symbol, bubble across the gate terminal. So channel is positive charge carriers, holds. So that's why it is a gate terminal is like a circle, a small bubble representation. Now it is a gate, drain and source. So Pmos enhancement. Pmos enhancement. Enhancement. In NMOS inverter, pull-up is depletion mode transistor. So both are NMOS, but pull-up is a depletion mode, pull-down is enhancement. Now here, replacing the depletion mode with a Pmos transistor. Pmos transistor. So stick diagram for this. Stick diagram for this. Red over yellow with yellow. Red over yellow is a stick diagram representation. You see, this is red over yellow. Now this one is a gate terminal, gate and drain and source. Drain and source. So what is the color representation here? drain and source is yellow color. Now polysilicon for both transistor gate is red color representation. A red color representation. Here also red color representation. Now in NMOS diffusion, this is a green color. What is the stick diagram? Instead of a transistor symbol, instead of this transistor symbol in a circuit, we can represent with the color stick. So transistor symbol. So what are the terminals are here? Gate, drain and source. Gate is a red, drain and source is a N diffusion, is a green color. So transistor symbol is here, Pmos transistor. Gate and drain and source. Gate, drain and source. Gate is a red color same as in NMOS, but drain and source is a yellow color. Means P plus diffusion. So here we can take N, drain is our N plus diffusion. Drain is N plus diffusion. Source also N plus diffusion. We already discussed this. Here P plus diffusion. Pmos, drain and source are P plus diffusion. P plus diffusion. Here also P plus diffusion. You see this one. So N plus diffusion green, P plus diffusion yellow. So let us see a Cmos inverter stick diagram. This is a Cmos inverter. Pmos transistor is there, NMOS transistor is there. We have our respective stick diagrams and VDD VSS. Here VDD VSS are blue. VDD VSS color diagram. Color stick is blue color. Blue color. Input output terminals also. Input output also we can take blue. Metal. V in V out is also blue. Is a blue, right? We call it is a blue color means it is a metal. It is a metal layer. We use metal layer as a aluminum layer. Metal layer. Now contact area we can use black color. So black color. Let us see this one. Representation of stick diagram of CMOS inverter. Now let us see this one in stick diagram. Stick diagram of CMOS inverter. CMOS inverter. So the above one is first VDD VSS. VDD VSS are blue, right? VDD VSS are blue, and pull-up transistor. Pull-up transistor is Pmos. Pull-up transistor is Pmos. Okay, and pull-down transistor is NMOS. So the drain source are N diffusion. This is a P diffusion. Color representation is yellow color. Now the gate is common gate terminal. You can say polysilicon gate. Polysilicon is a red color representation. You see this one. And the interconnection point from Pmos transistor to NMOS transistor, we can use blue. Okay, and this is a blue input terminal. Blue is the output terminal. Now let us represent the input and output. This is VDD. Color is blue color. Okay, blue color. And V out, output terminal. Color is blue color representation. And VSS is ground terminal. And this is also metal, blue color. Color stick, blue color. So input terminal is blue color. Blue. Okay. Now here interconnection also blue color. Right, where the polysilicon is a red color. You see, both polysilicons are red color, and diffusion. So diffusion P plus diffusion drain and source is yellow color. This is a yellow color, and this one is a drain and source is a green color, and contact area is there. Contact area, when two layers are interconnection, that is a contact area. Here two layers are there. There is a black contact, metal and the metal and the yellow here, and diffusion, P plus diffusion and metal. Here also metal and green, N plus diffusion. Here also green and the blue, you see. And output terminal is here taken metal, right? Here also interconnection metal and the polysilicon, the black contact area. So where the interconnection point, we can take the black color. So why we use this stick diagram? So stick diagram is, instead of a transistor symbol, we can represent a color stick: gate, drain and source. So gate is a polysilicon, drain and source a yellow color. Okay, so according to this stick diagram, so we can design a transistor, or from the transistor circuit we can design a stick diagram, right? Now let us see the stick diagrams. So different logics we can use. Draw the stick diagram for that logic. Stick diagram for different logics. Different logics by using a Cmos inverter. By using Cmos inverter design style. Cmos inverter design style. In the Cmos inverter design style, we have different logics are there. You can draw the stick diagram for the different logics by using Cmos inverter design style. For example, let us take y is equal to a into b plus c complement is a logic. This is a logic. We need to draw the circuit diagram and stick diagram for this logic in Cmos design style. First you draw the circuit diagram. According to the circuit diagram, then we can draw the stick diagram, right? First let us see this circuit diagram. Both transistors are there. See, both transistors in Cmos, both transistors, Pmos and Nmos. Now Pmos is a complement of Nmos. Pmos is the complement of Nmos. First you draw the logic for Nmos enhancement, then you can draw the complement of Nmos, right? We can draw this a into b plus c. Okay, so first a is a series, b plus c are the parallel. You see this one. So a is series and the logic, b plus c are the parallel. So first you see the logic, b plus c, plus means OR logic, Nmos are parallel. So a into means AND logic. So in series, AND logic means series, plus means parallel, right? So according to this, you can draw the complement Pmos transistor. A is here series. Now A is parallel. B and C here parallel. B and C are in series. Now we can take A is parallel with the B plus C is here parallel. Now it will be series, right? This is a complementary Pmos transistor. Yeah, let us say this one, right? So we can join this and from here we can take as a output. From here we can take as a output. This is a circuit representation of a given logic. First you can draw enhancement. First you can draw enhancement mode transistor. Then you can draw complement of NMOS. Right? So bubble across this gate, bubble across this gate, bubble across this gate. So it is A, B, C. So A, B, C. Understood this one? A into B plus C is a logic. Some Boolean logic is there. Now, according to this, we can draw the circuit diagram and then stick diagram. Circuit diagram A is AND logic, B plus C are the parallel. So A is here series and A is parallel, B plus C are parallel, here is series. That's it. Okay. So what is a complement here? Complement is nothing but where pull up pull down is there, then it is a complement. Pull up pull down, it is act as a complement. Right? When we are using Cmos inverter, pull up pull down is there is a inverter. Pull up pull down of NMOS depletion, NMOS enhancement, that is a NMOS inverter. Right? So complement is both transistors are there. Pull up pull down, it is a complement inverter. So V out. Right? Let draw the stick diagram for this. Stick diagram, first we can draw the VDD VSS ma. Okay. VDD VSS or VDD and VSS. Okay. VDD VSS. Right. After that we can draw the yellow color is there. First, when you are drawing a circuit, you can take enhancement. For stick diagram, straight away we can take yellow color and joining of these two sources, same yellow color, and here also, and drain and source is green. Transistor A is in series, right? And we have two transistors are in parallel, the parallel representation. Okay, so here one polysilicon, here polysilicon, two polysilicons here, two polysilicon, because B and C, A is parallel with B and C, and A is here, red over green, red over yellow, red over yellow, red over yellow. Now B and C are parallel, red over green, red over green. Yeah, so from we can take output terminal. So from here to here we can take output terminal. Right, we can represent this. So blue color for blue for VDD. Okay, this is blue VSS, blue VSS. Now output terminal blue, V out is blue. Now let us take polysilicon. Terminals are A, B and C. Here A, B and C. Right. Now yellow color is a P plus diffusion. This is yellow color, and where the red is polysilicon. Red is a polysilicon act as a gate terminal. Right. Anything green is there. So green is for diffusion. Green. So green is for diffusion. N plus diffusion. Okay. Now contact area you can take interconnection over here, black contact. Okay, interconnection over here, black contact, and here also interconnection, diffusions. Here also interconnection. Okay, here also interconnection. Right. Here also interconnection, diffusions, and here also one interconnection for metal to metal as a output. So this is a stick diagram for logic A into B plus C complement in CMOS design style. Let us take another example. Second one, Y is equal to, what is the previous one? A into B plus C. Now let us take A plus BC. A plus BC complement. A plus BC complement. So let us draw the circuit diagram. Let us draw the circuit diagram and then stick diagram. So let us say this one. Circuit diagram is first we can draw VDD VSS, VDD VSS. Draw the logic of enhancement of NMOS. A is parallel and B and C are series. A, let us first draw the enhancement of A is parallel with the B and C. B and C are series. AND logic means series. AND logic means series. OR logic. OR logic means plus. OR logic means parallel. Right? So A, B and C. Now complement of this one. You can see complement of this one. A is parallel. A is series. BC. BC are series. BC are parallel. Right? Let us A is series of Pmos and B and C are parallel. B and C are parallel. So A is in series with the parallel of B and C. You can say this one. So from here to here we can take and output connection. So A, B, B, C, C we can connect. So input terminal A, B and C, right? A, B and C. In this input is given to the common input. Three inputs. It is a three input. A to A, B to B, C to C. Right? So this is a VDD. The terminals are input, VDD output, and ground terminal. So inputs are A, B, B, and C, C. Let us see the stick diagram for this. So what is the stick diagram? Stick diagram for this VDD VSS are blue color. VDD VSS are blue color. Right? VDD VSS are blue color. Okay. Now, before that, let me here. This is a Pmos because a bubble is here. Now, take the Pmos transistor. One Pmos transistor is here. One Pmos transistor is here. Okay. And then after the two parallel Pmos transistors, you can join them and green diffusion, right? N diffusion of A, N diffusion of B and C transistors, drain and source same color, we can join the same colors. Then after we can take polysilicon. So first one A is a polysilicon, red over yellow Pmos transistor, red over yellow Pmos transistor, red over yellow Pmos transistor. So B and C are parallel and A is in series with the B and C, B plus C. Now here one polysilicon for A and B and C are two polysilicons. This is one polysilicon, this is one polysilicon. B and C are parallel. Right? We can represent this in the colors. What is a blue color? So VDD is a blue color. So this is VDD VDD blue color and a blue color VSS, right? And also we have output terminal interconnection with this and we can take as a output, right? So Vout is also blue color. Vout is also blue color, right? Then represent a polysilicon input A, B and C. Here also A, B and C are parallel. B and C are parallel. Now interconnection point is there. Interconnection contact area. You can take black contact. So you see this is a black contact. This is a black contact. This is a black contact, and this is a black contact. Two layers are here: metal and the diffusion. Metal and the diffusion. Right. So this is a black contact area, black color for contact area. So contact area. Two layers are here. Now we can represent the color. This is a red color for polysilicon, right? Yellow color for B plus diffusion, green for N plus diffusion. You see, this is a green for N plus diffusion. Source and drain, and this is a P plus diffusion. So this one is a stick diagram for a CMOS inverter design style. So this is CMOS inverter design style. CMOS inverter design style, because both PMOS and NMOS are there. Design style, right? You see another example as we discussed in NMOS inverter stick diagrams. Y is equal to AB plus CD complement. Let us draw the circuit diagram, then stick diagram. Okay, so how many inputs are here? 4 inputs, A, B, C, D. AB are series, CD are series, and both are in parallel. First you draw the enhancement, then complement. AB are series, C, transistor, NMOS enhancement. Pull down transistor is enhancement, pull up transistor is PMOS. So AB and CD are series and both are in parallel. Both are in parallel. Okay, you can see this one. Okay, right? So AB and CD we got. Now complement of this one, right? ABR, now ABR parallel, ABR parallel, PMOS, and CD also parallel, CD also parallel, both are in series. CD also parallel, both are in series, right? See this one, and this is a PMOS transistor. We can take a PMOS transistor. This is a PMOS transistor, right? PMOS transistor. Now joining of this one, and we can take as a output, right? Take as a output, right? Let us take the symbol input terminals. A is the input terminal, B is the input terminal, C is the input terminal, D is a C and D are series. A and B are series and logic. Now complement. The complement. This is a complement, right? Complement. Complement. A and this is B, A, B, C and D. You see, and this one is a VDD, VSS, VDD, VSS, and Vout terminal, right? Let us take the stick diagram for this. Stick diagram for this. So in CMOS design, in CMOS style, CMOS inverter style, CMOS inverter style, right? Let us take the stick diagram. First VDD, VSS. VDD, VSS are blue colors. VDD, VSS are blue color. Now take this ABR parallel. ABR parallel means we can take this one, and if P diffusion, both are same color, we can join that both. And here one more P plus diffusion for C and D, both are parallel. So drain terminal, source terminal we can take, right? Another we have drain source of A and B, drain source of A and B, drain source of C and D diffusions, right? We can join these two because the same color we can join, no problem, right? So here red over yellow, A and B parallel, red over yellow, C, red over yellow, D. Now red over green, A, red over green, B, red over green, C, red over green, it is D. So 4 transistors are here. Now joining of this one, joining of from here to here by using a metal, and output is also metal, right? We can represent this VDD is a blue color one. This is a blue color, this is a blue color, VDD. So VSS, this is VSS and this is VDD, okay? And here also the interconnection is here, the interconnection of this one, right? So this one is output over here, a blue color. Output is a metal, blue color is taken, right? Anything you want to represent input terminals. So PMOS A, B are complement of NMOS transistor parallel, C and D are parallel. Here A and B are series, C and D are series, both are in parallel. Now interconnection point we can take. Interconnection point we can take. You see, this is the interconnection point. This is the interconnection point. Right here also some interconnection point. Interconnection point, series connection. Interconnection point, metal and diffusion. Here metal to metal. Interconnection point. Here also interconnection point. You can see here also contact area block. Okay, so this is completely stick diagram for this logic in CMOS inverter. Let us one more thing, design CMOS NAND. CMOS NAND. CMOS NAND stick diagram. CMOS NAND stick diagram. So how can you draw CMOS NAND and what is a stick diagram for this? CMOS NAND means so NAND is AB complement. So first we can draw VDD VSS. VDD VSS. NAND means AB. A and B are A and B are series. A and B are series and complement. PMOS is a complement. Parallel. Right? This is parallel and this is parallel. This is parallel. Okay. And here we can take output. So A, B are series and A and B are PMOS parallel. So VDD, VSS, V out. So what is the logic is ABR series means and ABR series and complement is there. Complement and pull up pull down is there. Complement. So it is an AND. Right. Let us see the stick diagram for this. VDD VSS are blue. VDD VSS are blue. First you can take this yellow P diffusion for A, P diffusion for B. Now green N diffusion for A and B. N diffusion for A and B. So yellow is there. Then we can take the two will be similar same. Now polysilicon. Two polysilicons are A and B are parallel and here A and B are series. A and B are series. So joining interconnection from here to here we can use a metal and as a output terminal. Like okay, let us see the representation terminals. Okay, A, B, A and B. We can join A, B, B. Two inputs are here, A and B, B and B. So common input is given. Two input CMOS NAND. Like okay, so it is a red color representation. Polysilicon is this is a red color. Now this one is a yellow color. This one is yellow color. Now this is blue. It is VDD and VSS. V out. Right, V out. It is blue color. Okay. Now contact area. The joining of diffusion and metal here. Joining of diffusion and metal here. Right here also diffusion and metal here. Metal. Two contacts are here and diffusion and metal over here and diffusion and metal over here. So black. So it is a black area. The color is a black contact area. Square box, it is a black contact area. See, it is a stick diagram. That is last one. You can see the fifth one. CMOS NOR gate. CMOS NOR gate. So CMOS NOR gate stick diagram. We'll finish this one. So CMOS NOR gate means A plus B complement. A plus B complement means A and B are parallel. The logic we should know first. Then you can draw the NMOS enhancement. Then complement is PMOS. So PMOS are series. Logic is A plus B complement. If you know the logic, we can draw the circuit very easily. Right? So output we can take. Now representation here. A and B. So V out is a logic. NOR means A plus B complemented. A plus B complement. A plus B means parallel, and complement is because of pull up and pull down. Pull up and pull down. A connection, B connection. So common input. Two inputs are here. Now this is VDD and this is VSS. Let us see this one in color stick representation, stick diagram. VDD, VSS are blue, as usual blue, right? You can take yellow color series N diffusion, P diffusion, sorry, P diffusion, right? And a green for N diffusion. This is a green. Both are in parallel. We can join this because of drains are same, right? How many polysilicon there? Two polysilicon. One polysilicon A, one polysilicon B are series here. These are parallel and interconnection. This diffusion to P diffusion to N diffusion. We using metal and output is metal, right? So we can take we can write the color representation. This is a blue. This is a blue VDD, okay, and VSS blue color, okay, and we have red color polysilicon A and B, right? Red color as a polysilicon, right? Green is a diffusion. Green is a N plus diffusion. Green is a N plus diffusion, right? The contact area is there. Interconnection terminals over here. You can see this one now, and we can see this one, right? And you can see this one. Contact area. So two layers are there. There is a contact area. The color is a black color representation. Black color. Okay. Right. And V out is here. This is a V out blue color. V out is blue color. P plus diffusion is a yellow color. Yellow. This is yellow for P plus diffusion. Green for N plus diffusion. Right. If any logic is given, so first you know the logic, then you can draw the stick diagram. First circuit diagram, then stick diagram according to the transistor symbol, right? This is completely representation of CMOS logic diagram, CMOS circuit diagram for given logic, and a stick diagram. So please subscribe this channel, like and share with your friends. Thank you.